Hello PreCalc. This is your Tuesday video after class on the 29th. So let's see what is in store for you. I just want to make some closing comments on the law of cosines. So let me reveal the law of cosines again. Here are the three renditions of the law of cosines. Notice that we can use them when we have a side-side-side situation, and we can also use the law of cosines when we have a side angle side. That's when two sides are known and the angle in between them. Now what you might ask, which one of these forms should I use? And if you know side, 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 and you're looking for the other three angles, it doesn't matter which one you start with. But if you know a side, and the angle in between, you must start with the form that has the angle that is known in it. So if we know angle B, you're going to start with this one, and so forth. So go ahead and use the law of sines with confidence and complete as much of the classwork as you have a chance to do tonight so we can all be on the same page. Let me give you the assignment. It was page 443, number 6 to 11. And just in case you need to see that, let me shine a light on it. 443. Wait a minute. 443, number 6 through 11. Here's what the problems are. Numbers 6 through 11. And now you have, if you don't have your book, now you have the work, well, you have all the problems that right in front of you. Just jot them down and catch up. We need to all be finished our law of cosines work so we can move on. All right, so with that, let's go ahead and go on to the next topic. We're actually going to return to the scene of the crime where we were before we entered into the law of sines and cosines. And that is talking about trig IDs. So I believe we have, 20-some trig IDs? And that's way too few. So we're going to add to our trig IDs and do a lot of the similar things we used to do with them. So let me get a blank piece of paper and we'll start that discussion. All right. I was wondering, and I'm sure you were as well, what is the sine of a sum? So we're going to look at the sine. Put something under here. All right, the sine of a sum. In other words, what is the sine of A plus B? Does it distribute like other quantities and expressions in algebra? So will it turn out to be the sine of A plus the sine of B? All right, that should be a burning question in our minds. So let's do an example that we know to see if this relationship holds true. Suppose I do the sine of pi over 3 plus pi over 6. So the reason I picked that is because I know the answer to that. Pi over 3 is 2 pi over 6 when I give it the common denominator. So it becomes 2 pi over 6 plus 1 pi over 6. So all that equals sine of 3 pi over 6, which is sine of pi over 2. All right, so again, I said this would be one that we know. So let's take a peeky poo at the unit circle. And we can see at pi over 2 right here, the sine is 1. So on this side of the equation, just from knowing these quantities, we got a 1. So now let's work out our relationship on the other side and see if it also is a 1. And then it's not a rigorous proof, but it at least it leads us to believe at least that this relationship is true. So let's see. I'm going to distribute the sign and see sine of pi over 3. So I'm going like this, and plus the sine of pi over 6. All right. So when I do that, I know the sine of pi over 3. So that's right here. So we go over 1/2 and up the square root of 3 over 2. So the sine is the second. So for the first part here, we get square root of 3 over 2. And sine of pi over 6 would be right here, where the second coordinate would be, we go over square root of 3 over 2. And up 1/2. So 1/2 would be our value here. So I'm not sure whether square root of 3 plus over 2 plus 1 over 2 equals 1 or not. So let's keep going. Square root of 3 plus 1 over the common 2. So how about if I just plug that into the calculator? When I do, I get a 1.37, square root of 3 plus 1 quantity divided by 2. So now we can see clearly that 1 does not equal 1.37. So these are not equal, these are not equal, these are not equal, these are not equal, and that initial conjecture is not equal. So what if that is not the sign of a sum, what is? Alright, here's what my conjecture is. I think the sign of a plus b is the sine of a cosine of b plus cosine of a sine of b. Is that your conjecture as well? Alright, let's try this one. We'll do it again. Sine of pi over 3 plus pi over 6. And we already did that one, and we knew it came down to a 1 on the left. So now let's see if it works out better for us this time. So this is our a quantity, and this is our b. So I'm going to replace a with pi over 3 and b with pi over 6. So sine of pi over 3 cosine pi over 6. So now I'm up to here, plus cosine pi over 3 sine pi over 6. Alright, so let's look back at the unit circle for the sine of pi over 3. This one is pi over 3. The second coordinate is square root of 3 over 2. And that's going to be times the cosine of pi over 6. So that's going to be this one, the first coordinate, which is also square root of 3 over 2, plus the cosine of pi over 3. Cosine of pi over 3, first coordinate, 1/2. I'm sorry, the cosine of pi over 3. Do I have that right? Let me see here. Okay, that's right. So cosine of pi over 3 was 1/2. And the sine of pi over 6, so that's right here, second one, is also 1/2. Alright, still working on the right. Square root of 3 times square root of 3 is 3. 2 times 2 is 4. 1/2 times 1/2 is 1/4. 3/4 plus 1/4 is 4/4 or 1. True, 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 also true. This is not a rigorous proof, but it can be proven, and we're going to go with it. Sine of A plus B equals sine A cosine B, cosine A plus cosine A sine B. So write that in the body of your comp book and also in the back where you're collecting your trig IDs and formulas. Alright, so at this point I'm going to go ahead, rewrite that one, and give you the other ones that we need. Sine of A plus B, again, is sine A cosine B plus cosine A sine B. Alright, that's what we just established. And I would like to know the sign of a difference. And the sign of the difference is identical to the sign of a sum, except right there we are going to have a change. And it's minus. Everything else stays the same. Alright, cosine of a sum is cosine A, cosine B, minus sine A, sine B. And lastly, cosine of A minus B is similar except for right there. Cosine A, cosine B, plus sine A, sine B. Alright, so when it comes time for us to memorize that, we are going to notice some patterns. For one thing, remember I did the sine of a sum, then the difference, sine of a difference, then I did cosine of a sum and cosine of a difference. Notice if I write them in that order, it's going to go various functions, but notice AB, 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 and AB, AB. So a strong pattern with the A's and the B's. Notice sine starts with sine, cosine, then a plus, cosine, sine, and it's identical for the difference except the SIGN in between the two expressions. But when I go to cosine, it starts with cosine, but it stays cosine, whereas these two took on the opposite functions. So we have cosine, cosine, minus sine, sine, and then we have to remember that, and cosine has a plus when it's a difference of two. So there isn't a memory jingle for this one. You just have to look at it, observe some patterns, and memorize it. Some memory work, now that we're back into trig IDs, some memory work is at hand right now. So let me show you what's coming up tomorrow. And if you have a chance, if you're caught up on your law of cosine works, you can work on some memory work tonight. So I'll show you that. Okay, dramatic pause there. Here is your memory work that you will see in your passports. Reciprocal IDs, easy peasy. Then quotient identities, the tangent and cotangent. Alright, simple wimple. Even and odd functions, we haven't used them as much, but you can recall and look back in your comp books where we developed that. And you need to know those to move forward. And so all of that, you have to know all three of that to get a stamp for that page. And then the second part is the Pythagorean IDs, which we have used on our tests. So they should be in there somewhere in your beautiful mind. And then we have sine of the other angle equals cosine of the angle. And we developed that in the past. but we haven't committed it to memory yet.